Hi again, ladies and gentlemen. As you can see, today is not a very sunshiny kind of day. Uh, in fact, it's not a very spring-like day. It's more winter. But, real quick, I want to give you a quick tour of our solar system. But I gotta walk over there. So, a quick walk around the stuffs. Everything looks horrible right now, but it's not even the end of our first year up here. First, I'm going to show you the majority of our solar panels. They're 500-watt Renogy solar panels. Those are 4 of their premium monocrystalline. That's one of their monocrystalline. And then there's 4 up there. The big 2 are 150-watt polycrystalline Renogy panels. The 2 smaller ones are 100-watt Renogy polycrystalline panels. There's our wind turbine. It's pretty breezy right now. That thing up here has not really been worth the effort, but it's only up 20 feet, and I've got enough stuff to go up 80 once the snow's gone. So it looks horrible. It's a mess, kind of because we're adding stuff as we go. So first, down here along the bottom, and then there, so far we have a total of 8 Centennial Group 31 deep cycle batteries. You can see here our battery bank voltage. Right now the batteries are floating, even with the crap solar conditions we have now. These terminals here are just where I'm tying all the pairs of batteries together. So they're arranged in pairs. And I draw, don't laugh at my bolts, or my nuts, excuse me. I draw from the positive one battery, the negative of the other battery. Both positive and both negatives are connected to each other. This is 4-gauge welding lead that I'm using. This here are where everything is connected to everything. The inverters are connected here. The solar charge controller is connected here. The wind turbine's output is connected here. The gauges, everything is connected here. This is just a shunt on the ground side for this tiny little doodad here that shows how many amps the inverter is pulling right now, what the current battery bank voltage is, how many watts, and how many kilowatt hours we've used since I installed that thing. Up here we have the MPPT controller for the wind turbine. The wind turbine generates 3-phase 110 AC. This rectifies it to DC and then does all the cool charge controller stuff. Down here is our PWM controller I got off Amazon for the solar panels. Right now we're getting let's call it between 4 and 4.3 amps of solar power. If I remember right, our setup is capable of about 78 amps or so, 77, 78. And this is an 80 amp controller. Back here is the brake for the wind turbine. Excuse my horrible wiring and this mess. We just kind of jammed everything in here. This is our Iota battery charger for the less than sunny days. It is not tied to the studs that the inverter and everything is tied to. It's tied to the studs that join the battery bank. This is our inverter. It's a 1,000-watt inverter I got at Walmart for $100. It's modified sine wave. It works, but not the ideal. This outlet and light switch, I don't want to hear anything about the wiring either. It's only temporary. Here's the light, and then there's wiring running. I have lights on the other side for the bathroom. This is plugged into the inverter. It's this plug right here. This is a LED 110 light bulb. I don't remember how many watts or anything it was. It was pretty small. 5 watt, 139 milliamp, 120 volts. So, woo! Good thing for the cat-like reflexes. Milliamps, right? We're talking about milliamps. If you watch the amp side, remember this is what the inverter is putting, or what's the inverter is drawing right now out of the battery bank, 2.66 amps. Right now that's pretty much just the standby for the trailer and then the power consumption for the inverter. Now I'm going to turn that 5 watt LED 110 light bulb on. So we're up to 326, 351, 52. So that added almost another amp of draw, but the bulb only pulls milliamps. It's really inefficient to convert DC to AC. So we need to do as much stuff with 12 volts as we possibly can. Now I'm going to walk over here and show you the other battery, or the other solar setup we're running. That setup is 1,050 watts of solar panel, wind turbine 600 watts, and then we have 1,200 amp hours of battery. There's our generator. Again, excuse all the ghetto stuff. There are 3 310 watt Renogy panels, another 3 310 watt Renogy panels. And here it is. It says 8 Trojan T105s. This battery bank is 24 volt instead of 12. So we're pulling positive one end, negative the other end, and then everything is tied together. It's all full gauge welding lead. Setup is very, very similar in a lot of ways. Power flows in every direction from here. These two bus bars, and I didn't show them in mine because they're hard to see, is a solar array. I had this set up because we were initially running more than one array on this controller. Here is one 40 amp PWM controller. As you can see, it's unhooked because the PWM and this MPPT, well, they just don't play well together. So this has also got a light in it. This is power flowing out of the inverter to my mom's trailer. Down here we're running 2 Iota DLS 2740s to charge the battery bank. You can see her batteries are currently at 28 volts. They go up to 29.3, 29.4 to float, so they're not too far off. Her panels are on this MPPT controller are wired in series, where everything else is wired in parallel. Right now, with these horrible solar conditions and snow falling, those panels are generating 114 volts and 0.9 of an amp. The controller's outputting 28.1 and 5.2. Yeah, that's it. So the way it works is when I start the generator and the generator starts generating electricity, these two chargers will come in line, and they'll go initially in bulk charge mode. They're capable of 1,200 watts apiece, and they will just dump that into these 8 batteries until they reach a predetermined voltage, at which point they'll hover there for a minute, drop down to absorb mode, and drop the voltage down a level, and just charge a little bit slower. And once they reach a predetermined amount of time, they'll drop into float mode, which is where we're trying to get to now. Float mode is just like trickle charging the batteries. I try not to run the generator enough to cost me a fortune in fuel, but those two Iotas pull a lot of power. I run the generator about an hour and a half in the morning, usually here lately, and it'll take her battery bank from about 80% charged in the morning to 100% charged in 15 minutes tops. Those 8 Trojan T105s come out to 450 amp hours at 24 volts. The reason I'm running her setup at 24 instead of 12 is because as you double the voltage, you half the amperage. So on her setup, I could run 1180 watts of solar panel or so, and those 3 panels come out to 960 watts. Running her setup at 12 volts, I could only run 540 watts. So I hope you've enjoyed this, and I hope you enjoy the beautiful quiet